Hello everyone, welcome to the next lecture on the differential equation with the Laplace transformation. Today I will explain you with the help of the more than 10 examples in this lecture. Myself Dr. Harish, you can follow my YouTube channel where you can find the playlist of the mathematics 2 and you can see the various lectures related to the inverse Laplace convolution examples and many more available in these lectures. The theory part of this today's lecture is covered in this video. So let's start with this. What is the objective of this lecture is we will see how you can solve this Laplace, how you can solve the differential equation with the help of the Laplace transformation. So if you look about closely about all these differential equation, we all needed the derivative of the Laplace here. How you can find the derivative of this function. So for that, the first result is if f is exponential order and f dash is my continuous, then you have to prove this result. The result is very simple. How you can prove that? I can start from the left hand side. I can apply the definition of the Laplace. So it's from 0 to infinity e raised to power minus s into t f dash of t. Now you can integrate by parts. I can consider this the first part, this is the second function. So what is the integration of this first function? Integration of the second. What is the integration of the f dash? It is f of t from 0 to infinity minus 0. What is the derivative of the first function? Into minus s. Integration of the second function is f of t. Now if you substitute infinity, then e of minus infinity is 0 and f is my exponential order, so that means this is my 0. When you substitute 0, e raised to power 0 1, it is f of 0. Since this integration is with respect to t, so I can consider minus s is constant, which is outside. So minus e raised to power s into t f of t into dt. So can you identify that which term is called as? This is the Laplace of f. So I written as L f of t minus f of 0, and you can see that is the required proof of this result. Similarly, the second result is how you can find the Laplace of the second derivative. So that will be s square Laplace of f, s square Laplace of the f minus s y of 0 minus y dash 0. Or if I call this in terms of the f, then we call this is my f. Now how you can prove that? Again very simple. So I can replace f to f dash in equation number 1. So what is the meaning? What is the left hand side? This is the f to the f dash and it's a derivative, it's a f double dash of t. The right hand side is s L of f dash minus f dash of 0. Now I can substitute this value from the equation number 1. It will be s L of ft minus is minus f of 0. Now clearly say if you open this bracket, you will get the same result as here, L square f L of f minus s f of 0 minus f dash 0. Similarly, if you want to find the Laplace of the triple derivative, you can find it by replacing f to be f double dash in the equation. Now, so whenever you are trying to solve this, we will use this derivative formula in the Laplace. So let's start with the first one. So take Laplace transformation on the both side. So take the Laplace transformation on both side. So first part is Laplace of the y dash 3 Laplace of the y, which is Laplace of the 2. So what is the Laplace of the y dash? I can use this s into Ly minus y naught, s minus y naught. There is no derivative, it is as such. Laplace of the 2 is 2 over s. I can substitute the y0 is my 1, so it is my s plus 3 of Ly. Y0 is my 1, so minus 1 is 2 over s. So can you find the value of this? This into Ly, which is 1 plus 2 over s. Make sure student, you can also solve this equation by the simple differential equation. If you solve them, the auxiliary equation will be here. Fine. This is my auxiliary equation. and that auxiliary equation will always be my coefficient of the Ly. This is the way you can check your answer in your examinations. So what is the Ly? 1 over s plus 3 plus 2 over s into s plus 3. So what is the value of the y? I can find the value of y as a L inverse. So y is L inverse of s plus 3 plus L inverse of 2s into s plus 3. So how you can solve this? The Laplace of this is my minus of 3t. I can solve this by partial fraction. It is s and s plus 3. So if I substitute s is 0, answer is 2 by 3. If I substitute s is minus 3, it will be minus 2 over 3. So the answer is minus of 3t. It will be 2 over 3. It will be minus 2 over 3 e raised to power minus 3t. So these two can be combined. So 2 over 3 plus 1 over 3 e raised to power minus 3t is the required answer of this problem. And you can check in your examination as y of 0 is my 1. That means it's the correct option. Look at this next one. Again, taking the Laplace transformation on the both side, minus 3 Ly dash 2 L of y is L of e of 3t. I can substitute this value. This is s square L of y minus s y of 0 minus y dash 0 minus 3 L of y dash else L of y minus y 0 plus 2 times L of y, and this is 1 over s minus 3. So I can substitute here. It will be s square L of y. y0 is 0, so this number is 0. This is 0. 3s L of y. This is 0 plus 2 L of y, which is 1 over s minus 3. So that comes to be s square minus 3s plus 2 L of y, which is 1 over s minus 3. Again, you can see if you write the auxiliary equation corresponding to this, it will be m square minus 3m plus 2, and you can see the same thing appear here. Always same thing appear always. So y will be L inverse of 1 over s minus 3. I can factorize it. The factor of this is s minus 1, s minus 2. Fine. Now how you can find the inverse of this? I can partial fraction. So I can written as s minus 3, then s minus 1, and then s minus 2. So if I substitute s minus 3 as a 0, s will be 3. So I can substitute s is 3 here. So it's a 1 over 3 minus 1, 2. 3 minus 2 is 1. So it's a half. What is the s is equal to 1? I can substitute 1 everywhere, here, here, and this is a 1 over minus of 2, and it is minus 1. So it's a plus half. When I take s is equal to 2, it is a minus of 1. It's a plus of 1. It is my plus 1. Fine. Now, when I can repeat, when you substitute s is equal to 3, you will get 3 minus 1, 3 minus 2. That is a 1 over 2. S is equal to 1. It's a minus of 2. It's a minus 1. So it's a plus minus 2 plus 1. And when s is 2, it is my minus 1, and plus 1 is my minus of 1. Now you can find the inverse. Half is outside, e raised to power 3 into t. Half is outside, e raised to power 1 of t. Minus 1 is outside, e raised to power minus of 2t is my right answer of this problem. And you can also see that y of 0. What is the y of 0? Half plus half minus 1, 0. Derivative is again 0 is the correct answer. Okay, again by using the Laplace transformations, I can start from here. Plus L of y is Laplace of the t. So it is s square Laplace of y, s y of 0 minus y dash here. L of y is my this. What is the Laplace of the t? Will be 1 over s square. Now I can make the pair of the sy. So it's a s square plus 1 into L of y, and this minus s on the plus is a plus of 2 plus 1 over s square. Again you can see the auxiliary equation of this is m square plus 1, which is same. So can you find the value of the Ly? it is s over s square plus 1 plus 2 over s square plus 1 and plus 1 over s square plus 1. So the y will be L inverse s over s square plus 1 s inverse L inverse 2 over s square plus 1 and s 1 over s square of s square plus 1. So what is the answer of this? I can found right here. What is the Laplace inverse of this? It is my cos of t. What is that? It is a plus 2 is outside, it's a sine of t plus, how you can find this? I can use the partial fraction firstly. So I can return this is s square and s square plus 1. So it is plus 1, it is my minus 1. Fine. So now it is my cos of t plus 2 sine of t. What is the Laplace inverse of this? It's my plus of t, it is my minus sine of t. So this sine t and this sine t will be combined. So cos plus sine plus t is the right answer of this problem. And you can again see that y of 0 is 1, cos 0 1, sine 0 0, 0 is 1. What is the y dash is? Minus sine t plus cos t plus 1. So clearly say at the 0, 1 plus 1 2. You can always check your answer in the examinations. So look at this one. So I can start with the Laplace of this. 25 is constant, which is Laplace of 0. So I can substitute here. This is s square, Laplace of y, s y of 0, y dash of 0 plus 25 Laplace of y, Laplace of 0 will be 0. So it is a s square. What is the y of 0? Y of 0 is 1. What is the y dash 0? So since y dash 0 is not given to you, so you can take y dash 0 is my k. If anything is missing, you can substitute as a constant. So this is k plus 25 L of y is my 0. So make sure that you have to substitute the y dash. Y dash is not given, so I can assume that y dash is my k. So it is s square plus 25 L of y. The rest thing I can put on the right hand side. Again you can see this is my auxiliary equation of this. So can you find the value of the Ly? L of y will be s over s square plus 25 plus k over s square plus 25. Now you can find the value of y, which is L inverse s over s square plus 25 plus k is my constant, which is outside, L inverse 1 over s square plus 25. Now can you find the answer of this? So y is, this will be my cos 5 into t plus, how you can do that? I can multiply by 5 and divide it by 5 so that it becomes a sine. So it's a sine of 5 into t. Now since k is my unknown, how you can find that? Now I can use this value. So what is the value of the y? Pi by 2. It is my minus 1. Fine. This number is given to you. Now I can substitute here. What is the y of? So it's a cos 5 by 2. So 5 pi by 2 I can written as pi by 2 pi plus of this. So it is my cos pi by 2, which is 0, plus k over 5. It is my sine pi by 2. 5 pi by 2 is a sine pi by 2 is my 1, which is minus 1. So k will be minus 5. So what is my solution? Solution will be cos 5t minus 5, k is minus, so minus 5 of this. So that is the right answer of this problem. If you solve this problem with the help of the auxiliary equation and substitute this value, again you will get the same answer. Okay, again I can start with the Laplace of this. It is a s square, Laplace of y, s into y of 0. Y of 0 is my here, minus y dash is this, plus 2 times s of Ly minus y0 plus L of y, which is 6 is outside, Laplace of t e raised to power minus t So I can make the pair s square plus 2s plus 1 of Ly. What is the Laplace of this? So clearly say I can find the Laplace of the t. It is 1 over s square. Then by using the shifting first theorem, I can return this number is 1 over s plus 1 whole square. So it is 6 over s plus 1 whole square. Now I can find the value of the L of y. It is 6 over s plus 1 whole square. And what is that? This is again s plus 1 whole square. So y will be Laplace inverse 6 over s plus 1 whole power 4. So can you find the inverse of this? I can use the shifting first theorem, minus 1 raised to power t 6 over s raised to power 4. Fine. So what is the Laplace of this? 6, that is I can written as a 3 factorial. So that means this is my t cube e raised to power minus of t is the right answer of this problem. You can also see that y of 0 is 0 and derivative is also 0. Okay, what is that? This is the unit step function. And if you remember that, what is the unit step function of this? T Laplace of this will be e raised to power minus as over s. Now I can apply the Laplace s square L of y s y of 0 minus y dash minus 3 s Laplace of y minus y0 plus 2 L of y. What is the Laplace of this? I can compare. A is my 1, so minus 1s over s. So I can open this bracket. So s square minus 3s plus 2. This is my L of y. The remaining thing is minus s minus 1 plus 3, which is e raised to power minus 1s over s. So I can return this is s minus 1, s minus 2, L of y, which is equal to, this is my s, it's a plus of 2, I can return minus of 2, minus 1s over s. So what is the L of y? So I can return this is s minus 2 over s minus 1, s minus 2 plus e raised to power minus s, s minus 1, s minus 2. So y will be L inverse. So this number will be cancelled out. 1 over s minus 1 plus Laplace inverse e raised to power minus 1s s, s minus 1, s minus 2. Now how you can find the Laplace inverse of this part? So what is the Laplace inverse of the first component? E raised to power minus t. How you can find the Laplace of this? So there are the two cases. The first one is a is my 1, so greater than or equal to 1, otherwise 0. Fine. What is the rule is? I can find the Laplace inverse of the remaining quantity 1 over s, s minus 1, s minus 2. Whatever the answer we have obtained, I can replace the value to be t minus a. A is my 1. So firstly I can find the Laplace of this. So what is the Laplace of 1 over s, s minus 1, s minus 2? I can use the partial fraction s, s minus 1, s minus 2. So when you substitute s is equal to 0, its number is my half. When I substitute s is equal to 1, it is a 1, it's a minus 1. When I substitute 2, it's a 2 and it's a 1, so it's a half. So what is the Laplace of this? Half 1 minus 1 e raised to power 1 into t, half is outside, e raised to power 2t. Now I can substitute this value here and replacing t to be the t minus 1. So that means Laplace inverse of e raised to power minus 1s, s, s minus 1, s minus 2, it will be half e raised to power t minus 1, half e raised to power 2 of t minus 1. Fine. You can take the two cases u, that means whenever t is my greater than 1 and whenever less than 1 it's 0. So I can substitute this value at here. So it's a half minus e raised to power t minus 1 plus half e raised to power 2 t minus 2. Otherwise 0 is the right answer of this problem. Again you can see this is my unit step function. So firstly I can write this function in the unit step function. It's a twice of u t minus lower limit minus u t minus pi. Fine. So this is a unit step function. For more detail you can watch this lecture how you can write the example of the unit step function. So that's more than 17 examples are there that will help you to write this one. And it's a 0, it's a 0. Now you can take the Laplace on the both side. So s square L of y, s into y of 0 minus y dash plus 9 L of y, which is twice. Again, what is the u of t minus a? I can use the same rule here. It's a t minus a e raised to power minus as over s. In this case, this is my 0, e raised to power 0s over s, e raised to power pi s over s. So what is that? It is my s square plus 9 L of y, which is 2 over s 1 minus e raised to power pi s. Fine. So again you can see this is the auxiliary equation. So y will be Laplace inverse 2 into 1 minus e raised to power minus pi s divided by s of s square plus 9. Fine. So I can also written this quantity as 2 is my outside. So this is Laplace inverse 1 over s square plus 9 minus Laplace inverse e raised to power minus pi s square plus 9. Fine. So how you can find this first quantity L inverse of? So I can find the firstly the Laplace inverse of this number 1 over s. Either you can use the partial fraction or there is no need to, because it's a 1s, so I can integrate from the 0 to t Laplace inverse of the remaining quantity s square minus 9 of this. So what is the Laplace inverse of this? I can multiply by 3 and divided by 3, then it will be my sine of 3t. So this is my sine of 3t. Fine. Now what is the Laplace? What is the integration of the sine 3t? It's a minus cos 3t over 3 from 0 to t. So minus 1 over 9 I can take it is outside. It's a cos 3t, cos 0 will be 1. So I can adjust the negative. It is 1 over 9, 1 minus cos 3 into t. So this answer will be 2, 1 over 9, 1 minus cos of 3t minus. How you can find this? Again, it's exponential part. So I can find the Laplace of the remaining things and replace small t to be the t minus a. What is the a in this case? Pi. So what is the remaining thing is 1 over s square plus 9. So I already computed s here. So therefore, what is the Laplace inverse of e raised to power minus pi s square plus 9? It will be two cases when t is greater than of pi and t is less than pi. It is 0. So what is that? It is, I can replace t to be t minus pi. Fine. Or what is that? I can return this number is cos of, so this value is 3t minus 3 pi. So this I can also be written as 3 pi minus 3t, because cos negative is always positive. So in which quadrant it lies? It lies in my second quadrant. It's a negative cos 3t. So this number will be 1 over 9, 1 plus cos of 3t. and 0. This and here. You can see that 2 pi plus pi, this is 3 pi. 3 pi minus is lies in the second quadrant. In the second quadrant, cos will be negative. So here. So finally, you can write this answer as here. So minus 1 over 9, 1 plus cos 3t. You can write in terms of the unit function u of t minus pi. Otherwise, you can write in the two cases as you can write as here. Fine. So that's on your choice whether you write in the unit step function or in the two different cases. Okay, look at this next one. Again the Laplace transformation. So I can apply the Laplace of this. So s square L of y minus s y0 minus y dash 0 minus 6 s L of y minus y0 plus 9 L of y, which is L of t square e raised to power 3t. So y of 0 is my 2. So s square L of y minus 2s. Y dash 0 is my 6. This is s Ly minus of 2 plus 9 L of y. What is that? Can you find the Laplace of the t square? It will be 2 over s cube. Then I can apply the shifting first theorem. So it is a s minus 3 whole cube. Then I can make the pair of s square minus 6x plus 9 of Ly, and the remaining thing is minus 2s minus 6 minus plus 12 over s minus 3 whole cube. Again you can see that the auxiliary equation of this will be same. So this number I can written as s minus 3 whole square L of y. I can put this quantity on the right hand side. So this is my 2s. It will be plus 6. I can written as a minus 6 plus twice of s minus 3 whole cube. So I can find the value of the Ly. It will be twice 1 s minus 3 will be cancelled out plus twice s minus 3 raised to power 5. So can you find the value of the y? It is L inverse 2 over s minus 3 plus L inverse 2 over s minus 3 raised to power 5. So what is that? This is twice e raised to power 3 into t. I can apply the shifting first theorem. 2 is outside, e raised to power 3 into t, L inverse 1 over s raised to power 5. How you can solve that? E raised to power 3 into t plus, how you can do that? I can multiply by 5 gamma divided by 5 gamma. Gamma of 5 will be my 4 factorial. This is my t raised to power 4. So the right answer is e raised to power this. 4 factorial is 24. So 1 over 12 e raised to power 3 into t e raised to power 4 is the right answer of this problem. And you can see also y of 0 will be 2, y dash 0 will be 6 is the right answer of the problem. Okay, look at this another one. Again I can apply the Laplace transformation. So s square this minus sy0 minus y dash 0 plus L of y, which is L of 3. Now I can substitute the value s square. Y of 0 is my 1. Y dash 0 is not given to you. So I can simply take y dash of 0 is my k. So minus k plus L of y. Laplace of 3 will be 3 over s. So I can make the pair s square plus 1 L of y, which is s plus k plus 3 over s. So what is the value of the Ly? S over s square plus 1, k over s square plus 1 and 3 over s square plus 1. So can you find the value of the y? Y is L inverse of s square plus 1. K is my constant. L inverse 1 over s square plus 1. 3 is constant. L inverse 1 over s plus 1. So it will be cos of t, k is outside, it is a sine of t. How you can do? Either you can use the partial fraction, otherwise because s is written, you can use as a integration of this. Laplace inverse of 1 plus s square, sorry, it's s square, so that will be sine of t. So what is that? So y is cos of t plus k sine of t plus 3 times, what is the integration of this from 0 to t? Is 1 minus cos of t. Now you can use y of pi by 2 is 1, it is given, to find the value of this k. So what is that? It's a 1, sine pi by 2 is a 0, cos pi by 2 is a 0, sine pi by 2 is my 1 plus 3, 1 minus 0. So that implies 1 is k plus 3, k will be minus 2. So therefore solution will be cos of t minus cos of t. So I can written as minus twice cos of t minus twice sine of t plus 3 is my right answer of this problem. Look at this another one. Again I can apply the Laplace transformation. Is L of y, s into y0 is a 0 minus y dash plus 4 s L of y minus y0 plus 4 L of y. Can you find the Laplace of this? What is the Laplace of that t? 1 over s square, and if I apply the exponential, it means shifting first theorem, so 1 over s plus 2 whole square. Now I can make the pair. It's a s square plus 4s plus 4 of Ly, s0 minus of 2 plus 0, so that's a minus of 2, 1 over s plus 2 square. Now clearly say again this auxiliary equation. So can you find the value of the Ly? Minus of 2 I can written on this side, so s square plus 4s plus 4 plus s plus 2 whole square and s square plus 4s plus 4. How you can do that? Is a 2 over s plus 2 square plus, again it's a square, so it's a s plus 2 raised to power 4. Now what is the value of the y? I can take as a L inverse. L inverse of this, L inverse of this. So what is the value of this? It is, I can apply the shifting first theorem, e raised to power minus of 2t, L inverse of 2 over s square plus, again I can apply the shifting first theorem, minus of this, L inverse 1 over s raised to power 4. Now I can take this 2 as the outside, so it is y is equal to twice of this. Now I can, it's a 1 over, so it will be y is equal to 2 e raised to power minus, what is the Laplace inverse of this? T. What is the Laplace inverse of this? I can multiply by 4 divided by 4 gamma. 4 gamma is nothing but 3 factorial, that's a 6, it is my t cube. So that's the right answer of this problem. Look at this next one. Again I can apply the Laplace transformation. Minus y0 is a 0 minus y dash plus twice s Laplace of y minus 0 plus 5 L of y. How you can find the Laplace of this? I can find the Laplace of the sine, it is 1 over s square plus 1, and apply the shifting first theorem. Fine. Now you can make the pair. It's a s square plus 2s plus 5 L of y. This minus 1 I can put on the right hand side, plus s plus 1 whole square plus 1. So can you find the value of the y from here? This is L inverse 1 over s square plus 2s plus 5 plus L inverse 1 over s plus 1 whole square, this is the first value, and s square plus 2s plus 5. Fine. Now how you can solve that? I can completing the square. because factor is not possible, so I can make them as a completing square, s plus 1 whole square plus 4 plus L inverse, this is s plus 1 whole square plus 1 and s plus 1 whole square plus 4. Now how you can do that? I can apply the shifting first theorem, e raised to power minus 1t L inverse 1 over s square plus 4 plus L inverse. Again I can apply the shifting first theorem here, so it will be e raised to power minus 1 into t L inverse 1 over s square plus 1 s square plus 4. Fine. Now that is over. So what is the first part of this? It is e raised to power minus 1 into t. What is that? I can multiply 2 and divide it by 2. It's a sine of 2t plus e raised to power minus 1t is outside. I can use as a partial fraction. So it's a s square plus 1 and s square plus 4. So when I take s square is a minus 1, it is my 1 over 3. When I take s square is equal to minus 4, it is my minus 1 over 3. So what is the right answer of this? E raised to power t sine 2t divided by 2. 1 over 3 is outside. E raised to power minus t. Fine. What is the Laplace of this? It is my sine of t minus, what is that? It's a sine of 2t divided by 2, because you have to multiply and divide it by 2, and that is the right answer. Or you can do the more calculation. It's a sine of 2t will be the common and you will get the right answer. Okay, look at this another one. Again I can apply the Laplace transformation. S y of 0 is 1, y dash 0 is 0, minus 3 s minus 1 plus 2. What is that? It's a 1 over s. It is 1 over s minus 2. So I can factorize them. It's a 3 this plus 2, that's the coefficient of Ly. It's a minus s. It's a plus 3, minus s plus 3, which is 1 over s minus 1 over s minus 2. So I can find the value of Ly from here. So it is s minus 3 over, I can factor this also, s minus 1, s minus 2 plus 1 over s, s minus 1, s minus 2, 1 over s minus 1, s minus 2 whole square. So what is the way? Y is L inverse of this quantity, s minus 3, s minus 1, s minus 2, L inverse 1 over s, s minus 1, s minus 2, L inverse 1 over s minus 1, s minus 2 whole square. So how you can find the Laplace inverse? I can use the partial fraction. So I can write for you here. This is s minus 3, s minus 1, s minus 2. So can you find the partial fraction of this? It is L inverse s minus 1, s minus 2. So what is the answer of this? When you substitute s is equal to 1, it will be minus of 2. It will be my minus 1. It is my twice. When you substitute 2, 2 minus 3 is minus 1. 2 minus 1 is 1. So it is my minus 1. So what is the Laplace inverse of this? 2 e raised to power t, e raised to power minus 2t. That is my first component. Second part is 1 over s, s minus 1, s minus 2. So L inverse 1 over s, s minus 1, s minus 2. So because all are my linear, so I can written is s, s minus 1, s minus 2. So when you substitute s0, it's a minus 1, minus 2, it's a 1 over 2. When you substitute 1, it's a 1, it's a minus 1, it's a minus 1. When you substitute 2, it's a 2 and it's a 1, it's 1 over 2. So what is the Laplace inverse of this? Half it is minus e raised to power t, it is half e raised to power 2t. And look at the last one, Laplace inverse of 1 minus s minus 1 and s minus 2 square. So how you can write that? It is, firstly I can find the Laplace inverse. Firstly I can write the partial fraction because this is the quadratic. So I have to return s minus 1, sorry, I can return here plus s minus 2 plus s minus 2 square. So this value is same as such here, so I can substitute s is equal to 1 in this case. It is 1 minus 2 square, that is a 1. S minus 2 is not written, but it's a square, so I can find the coefficient of this directly. I can substitute s is equal to 2, so 1 over 2 minus 1, 1. How you can find this? I say this is my a. How you can find this coefficient? Again very simple, I can simply put s is equal to 0 in this equation. So this is my minus 1, it is my 4, it is 1 over minus 1, it is a over minus 2, and it is 1 over 4. So this is my minus 1 over 4, it is my plus 1, it is minus 1 over 4, this is minus a over 2. So what is the value of this? It is my half, it is my minus a over 2. So a will be my minus 1. So I can substitute here, a is my minus 1. Then I can take the Laplace inverse. What is the Laplace inverse of this partial fraction? The first value will be e raised to power t. Second value is minus e raised to power minus 2t. This will be, I can use the shifting first theorem. What is the Laplace inverse of this? E raised to power 2t, Laplace inverse of s square. So that will be t e raised to power 2t. Fine. Now that is the Laplace inverse of all these three quantities. Now I can substitute all these values here. What is the Laplace inverse of the first part? That is twice minus e raised to power minus 2t plus second part. Second part is half minus e raised to power t, half e raised to power 2t minus third quantity minus e raised to power t minus minus plus e raised to power minus of, sorry, it's a plus of t. So plus e raised to power this and minus t times e raised to power 2t. Fine. Now you can do that calculation. So what is that? This will be cancelled out. E raised to power 2t and e raised to power of this. So one is a half is constant. This and this will be minus half e raised to power 2t plus of this. It will be my plus of half again. Fine. Or you can see this and this will be cancelled out and it will be minus is the right answer of this problem. So this is the way you can solve all these Laplace transformation question in a very simple manner. These questions are exercise for you, these 7 questions and their respective answers. Again, the total 15 question I have put for you. You can solve it and let me know if you have any doubt in the comment box. I hope you can like, share and comment on my video. Best of luck students. Happy learning.